In our final series, we will discuss various topics which include acids, bases and salts, energy reactions. In this lesson, we will discuss electrochemistry. This is a branch of chemistry that deals with the relationship between electricity or flow of electrons and chemical reactions. This is an introduction to oxidation-reduction reactions, also known as redox reactions. Redox reactions or oxidation-reduction reactions primarily involve the transfer of electrons between two chemical species. The compound that loses an electron is said to be oxidized. The one that gains an electron is said to be reduced. A redox reaction is a reaction in which there is simultaneous transfer of electrons from one substance to another. One substance loses electrons and those electrons are gained by another substance, thus two processes takes place in a redox reaction. Gain of electrons and loss of electrons. The word redox is derived from two words. Red is from reduction, which describes the gain of electrons, and ox is from oxidation, which describes the loss of electrons. Zinc atom loses 2 electrons to get oxidized to zinc ion. The process is referred to as oxidation. The copper ion gains 2 electrons to form copper atom. The process is known as reduction. Two processes combined are referred to as redox. The oxidizing agent is the species that is being reduced, and the reducing agent is the species that is being oxidized. It is the number of electrons gained or lost by an element. If an element has not lost or gained an electron, its oxidation number is 0. When an element gains 1 electron, it acquires a negative charge of -1. The oxidation number -1. If an element gains 2 or 3 electrons, then the oxidation number is -2 or -3. When an element loses 1 electron, it acquires a positive charge of +1. The oxidation number is +1. If an element loses 2 or 3 electrons, then its oxidation number is +2 or +3. Oxidation numbers help to keep an account of the electrons in a compound and also during the reaction. The general rules to help assign the oxidation number to elements are listed below. However, as with all general rules, there are always some exceptions. Rule 1. The oxidation number of an uncombined element is 0. A molecule of the same element, the oxidation number of the element is 0. Rule 2. Alkali metals have +1, while alkaline earth metals have +2. Rule 3. Common oxidation number of oxygen is -2, except in peroxides like hydrogen peroxide, the oxidation number is -1. Rule 4. Common oxidation number of hydrogen is +1, except when combined with metals, as in sodium hydroxide or calcium hydroxide, it is -1. Rule 5. Common oxidation number of halogens is -1. Chlorine, bromine, iodine, Work out the oxidation number of the named element in each of the following compounds. Sulfur in potassium sulfate. Step 1. Work out the oxidation number of nitrogen in an ammonium ion. Step 1. Oxidation number of hydrogen is +1. Let the oxidation number of ammonia be X. Step In a redox reaction, the reduced species is the oxidizing agent, while the oxidized species is the reducing agent, as illustrated in the redox equation shown below. Zinc in solid form is the reducing agent, and it gets oxidized to zinc ions in aqueous form. Copper ions in aqueous form is the oxidizing agent, and it gets reduced. In this lesson, we will discuss displacement reactions as redox reactions.